Hi there. We are in Unit 9, Ecology, Chapter 5, Population Ecology. Population ecology is probably one of my favorite things to talk about and to think about because it's just really fascinating to think about how the relationships with organisms, how they impact each other. And that's what population ecology really starts digging into. We start looking at how we explore populations' range, their growth rate, density, distribution, and age structure when we think about how populations grow. So a range, and again, this is why I took the vocab out of this unit because a lot of it is stuff that you're familiar with. But when we're exploring a population's range, it's really where does the population live? And so in this instance, this map shows the range of the black widow spider. And it also shows predictions for where they think this spider is going to be moving or expanding its territory into. So that's kind of interesting. Growth rate is exactly how it sounds. It's the change in the size of a population. You take the births minus the deaths. All right. So your rate of population growth is how many people are being added to the population versus how many people are leaving the population. Density is the number of individuals per unit area. And this is showing the population density of people in the United States by county. So when we see the red parts, that's where there's more than 250 people per square mile. So those are densely populated areas. And you know enough geography to know that these are cities, and a lot of them are near the coast because that's where a lot of cities were established. Places that are very pale yellow, have less than 10 people per square mile. So that is the population density of the United States. Distribution is how individuals are spaced out across their range. There's three types of distribution: clumping, uniform, or random. In a clumped distribution pattern, you see groups of organisms kind of moving around together, and that's partly because it's safer like that. Uniform is kind of like how classrooms are set up. It's not very common, and you don't really see that in nature as much. Random, it's hard to determine, but you would see this when you think about, the little dandelion where you blow on the dandelion seeds and have them kind of fly all over the place. That could be random. The next thing to really think about is age structure, the age of the individuals in the population, and also if they're male or female. And something you might not consider as important, but it's really important, is the reproductive age range. So if we take a look at what this circle is representing, the circle is representing the reproductive age range for these populations. And think for a minute why that might be important to know how many individuals are of reproductive age. If you've said that matters because those are the individuals who are actually able to add to the population, you would be correct. And that's why when we're studying population ecology, one of the things we consider is not just the number of organisms, but also the number of organisms that are of a reproductive age. So, how populations grow. We've got a couple different types of growth patterns. And when we're exploring growth patterns, one of the terms I want you to keep in the back of your mind is carrying capacity. Carrying capacity refers to the number of individuals in a population that the environment can support. So it's all of the resources that are available to the individuals in that population, and can they be supported? I use this fishbowl because it shows you that if we have a couple fish in the fishbowl, there's enough food, there's enough resources, they can swim around and get some fishy exercise. But when we put too many, there's not enough resources, not enough space, not enough food, and they start to die, right? And possibly, like, they're all going to die because they've gone well beyond the carrying capacity. So, this is a growth curve. It shows the number of individuals versus the time. Logistic growth is one of our growth curves. And when you think of logistic growth, think of context clues and think of the word logical. Logistic growth occurs when a population reaches the carrying capacity for its environment and then starts to taper off. So we're no longer having a high growth rate where our growth is actually zero, which means the same amount of individuals are being born as die off, roughly. When you see growth rate at zero, that doesn't mean no one's being born. That means it's the same number being born that die off. An exponential growth pattern, you might be familiar with the term exponent from math. An exponent tells us how many times we multiply the base number by itself. So 2 with an exponent of 4 means 2 times 2 times 2 times 2, which gives you 16. So exponential growth means the population is rapidly reproducing. It's doubling itself with each generation. So if you have 2 rabbits and then those 2 rabbits breed and they each make 2 more rabbits and then those 2 rabbits breed and now we have 16 rabbits, it just continues and continues and continues exponentially. In an exponential growth curve, what you often see is the population size is exceeding the carrying capacity. Think for a moment what could happen here. We've gone beyond the carrying capacity, which, as you remember, is the amount of resources that the environment can support. So very often in exponential growth patterns, you end up with something called a population crash. You don't see a leveling off or a slowing down of population size. You see the population crash because now there are not enough resources for anyone. The environment has been exploited and the population crashes. Sometimes this leads to extinction, and sometimes it leads to just a very, very small population size, which we'll talk about later. Something interesting to research, I'd like you to take a second now and just research Easter Island and what led to a population crash on this island. Next thing to think about in how populations grow are growth patterns. You have your R strategists and your K strategists. R stands for rapid rate of reproduction, very little parental care. Our strategists are things like insects, they lay eggs and they don't worry about their babies. Frogs lay eggs, don't worry about their babies. They have a rapid rate of reproduction and they don't raise their kids. K strategists have a slower rate of reproduction, so they have a longer gestation period. Most of our mammals are K strategists because they give birth to their young and generally have a degree of parental care of their offspring. Next thing to talk about in section 5 is limits to population growth. And limits to population growth are called limiting factors. It's any factor that controls the growth rate of a population. Limiting factors can be biotic and abiotic. What I want you to think about for a second is, why can't you be a mer person? Like, you want to live in a pineapple under the sea. What's stopping you? Any of the answers that came to mind are probably correct. If you said to yourself, I can't breathe underwater, I wouldn't be able to secure enough food, my skin would get all icky. Like, we're not made to live underwater. So, those are all limiting factors that prevent us from being merpeople. Same thing with why we can't have toucans flying around Exeter. The environment, the resources, the climate, it's not made for tropical birds. This is not a tropical ecosystem. Those are limiting factors that control the growth rate of a population in an area. Two types of limiting factors are density dependent and density independent. Density dependent limiting factors depend strongly on the population density, or how many individuals there are per unit area. This is like this fishbowl. You've got competition, parasites and disease, stress from overcrowding, predation. Even humans can be predators. One of the things we're going to think about is the population of the moose and wolf on the Isle Royale. We're going to notice that as the wolf population goes up, the moose population comes way down. And then as the wolf population comes down, the moose population goes way up. So this is kind of an interdependent relationship between the moose and the wolf. Density independent limiting factors are basically environmental. So, weather, hurricanes, droughts, floods, wildfires, it doesn't have anything to do with how many organisms there are. So, looking at our fishbowl example, whether you have all of these fish or just 3 fish, if you heat up the water in those fish bowls, all the fish are going to die. Same thing with density independent limiting factors. These natural disasters will happen regardless of whether there's people or a high population or not. One of the things that we think about when we study human population growth, and we're in section 5.3 right now, is the human population. For most of human existence, human population growth was slow and stable. So for most of our time here, however, something happened in the late 30s, 40s, 50s. It was the Industrial Revolution. Countries became more developed, food supplies became more reliable, the global human population began to grow more rapidly. This trend continued through the Industrial Revolution. Did I say the 1930s? I'm sorry. I was way off by like 100 years. In addition to improved healthcare, sanitation, and public health, they dramatically had a decrease to the death rate. Now, there's some who say that the carrying capacity for Earth is at about 7 billion. There's others that say the carrying capacity for Earth is over 10 billion. No one knows. And the reason that no one knows what the Earth's carrying capacity is because technology continues to help us move that carrying capacity bar a little bit higher. There's a lot of technology in agriculture, studying how to grow plants in vertical settings instead of across fields, different types of fertilizers, all sorts of technologies in agriculture to create more food, different ways to explore creating clean drinking water. So as we continue to grow the human population, the technology needed to increase the Earth's carrying capacity has been growing as well. So, what is the carrying capacity of the planet? We don't know exactly what that number is because technology continues to improve alongside of it. The human population clock is fun to take a look at because it shows you ads that we don't want to see. But the world current Earth's population close. Why won't that close? Is 7,800,000,000 people. These are how many have been born so far today. These are how many people have died so far today. You can see we find our rate by subtracting births from deaths. And that is our growth rate so far for this year. 22 million people have been added so far this year. Other things we can see on the human population growth clock is the population of some of our largest countries. China has, what is that there? 1,400,000,000 people. The United States has about 300 million people. So China and India, you can see, are much, much more densely populated countries. Much more densely populated. Okay. The growth rate of the global population has been decreasing. Now, not the total population, but just the speed at which the population is increasing. And when you study human populations, you're studying demographics. Demographics are factors that influence population growth. They're just sometimes economists study demographics to think about, you know, urban development and things like that too. So demographics is the study of human populations. That's basically what it is. There's factors that influence population growth: economic growth, stability of society, availability of birth control. In some of those countries on the world clock, birth control is not easily accessible to women. Social norms, government policy, healthcare standards, migration, cultural attitudes towards family size. In some cultures, it's revered to have very, very large families. In other cultures, not so much. Female labor market, like, do women hold off on having children until they're more established in their careers? Is that more of the normal thing for that culture, or do females start having children very young? So a lot of factors influence population growth. That is where we're going to stop with Unit 5. So it's an interesting unit, or Chapter 5, rather. I'm sorry. It's a very interesting chapter. If you have any questions, please ask me, and I'll review any of these concepts with you. And what you're going to want to do, just to reinforce some of this, is continue with the Chapter 5 reading, which is posted in Schoology, and then take your Chapter 5 reading quiz. Thank you.